All right, these are some of my favorite strategies: expanded form and partial sums. These two are going to be your lead-ins to what we're used to, what we grew up with, which is the traditional algorithm, the standard algorithm, or what you'll hear them call the stack. Okay? So expanded form, you're just going to pull everything out into its expanded form. So 435 turns into 400 plus 30 plus 5, breaking it out into the hundreds, tens, and ones. And 183 becomes 100 plus 80 plus 3, breaking 183 into its place values. So then we can tackle it. Starting in our ones, 5 plus 3 is 8. Jumping over to our tens, 30 plus 80 is 110. And then adding our hundreds, 400 plus 100 is 500. But there's 100 in the tens place. Danger. They can either add straight across 500 plus 110 is 610, and 8 more is 618. Or they can take that expanded form and go, there's 100 there. That kind of belongs in the hundreds place. And they can actually carry it over. They can regroup it to the hundreds place and then add down from there. So instead of having 110, they would have their 10 left in the tens place. With that new 100 in the hundreds place, it's not 500 anymore, it's now 600. So now they have 600 plus 10 plus 8 is the same as 618. Two ways, same exact answer. Partial sums. This one is kind of what a lot of us do in our brains already. We just didn't have a name for it. Partial sums, we're looking at adding our hundreds. 400 plus 100 is 500. Now we're going to go to our tens place. And yes, it's the digit 3 plus the digit 8. But they're in the tens place, so they're not 3 and 8. They're actually 30 and 80. Which is something our second graders have to keep thinking about. Because they see 3 and 8 and they want to say 11. Which it does make 11 digit-wise, but it's not worth 11. It's actually 30 plus 80, which gives them 110. And if you notice, that 100 for 110 is already sitting in the hundreds place now. Quite nice. So then they have to go over to the ones place and they go, well, 5 plus 7 is 12. And notice the 10 is already sitting in the tens place. This lets them remember, hey, these digits are actually worth more. They have a value that's different than what I'm seeing. So now they can add like a third grader and stack it up and get 622 because they got 002 in the ones place, 0, 1, and 1 in the tens place, and the 5 and the 1 in the hundreds place. Expanded form for subtraction. This is where they gotta pay attention a little bit more, and it can get a little twisted if they're not careful. But this helps them gain that groundwork, that understanding for the standard algorithm. So they remember, I'm not doing 3 minus 8. I'm actually looking at 30 minus 80. Still can't do it. But they have to know those things. If they don't know they're looking at 30 minus 80, things get a lot harder in third grade. So we're trying to give them that basis, that understanding in second, so that when they get to third, they can really tear through a lot of the work. So, expanded form, we're going to start in the ones, 5 minus 3, we can do that, it's 2. Then we jump to our tens place, 30 minus 80. Well, I can't do that, at least not in second grade. So we're going to regroup. We're going to borrow. Instead of 400, we'll leave that with a 300. And instead of 30, we're bringing 100 over. We're bringing 10 extra tens in. So now we have 130. Now I can take 80 out of that. And when I do, it gives me 50. They can use a picture to help them out with that. They can count up 80, counting on 90, 100, 110, 120, 130, and figure out, oh, that's 5, so that's 10, 50. And then we tackle the hundreds place. 300 minus 100 is 200. So they should figure out that the difference is 252. You might be asking about partial differences in subtraction. It's a very different world than partial differences in addition. So it not really diving into that just yet, because it's definitely more complicated when they have to borrow things. They can't just do hundreds, minus tens, minus ones, because things get wonky very quickly.